All right, so hopefully you had a chance to try the drill. I'm going to go over it, and then we'll get right into the lesson. So we need to factor each and state the zeros. So this goes back to the beginning of the unit. These are not perfect squares, so I don't see a pattern here. So I probably just need to say, okay, C is equal to 20, and B is equal to 12. So let's say 2 times 10, right? So we want to do 2, and we want to do 10. This is a leading coefficient of 1, so truthfully, I could just drop these into factors, but in case you didn't see that, I want to show you the grouping one time at least. So x squared plus 2x plus 10x plus 20, and then I group the front 2, pull out an x, and I have x plus 2. I group the back 2 and pull out a 10, and I'm left with x plus 2. And so my factors are x plus 2 and x plus 10. Okay, so I could have just taken this 2 and the 10 and thrown it in there just like that and been fine. Then it wants me to find the zeros. Well, that would be if my expression was actually equal to 0. Okay, so I factored it and then stating the zeros. What would make this factor 0 would be a negative 2. And what would make this factor 0 would be a negative 10. So it is factored, and I have stated the zeros. On my second one, I need two things that when I multiply them, I get 54, and when I add them, negative 54, and when I add them, I get negative 3. I'm thinking along the lines of negative 9 and positive 6. So I believe it's going to be x minus 9 and x plus 6. So if I set that equal to 0, I could come up with the zeros of x equals positive 9 and negative 6. So there it is in factored form, and the zeros. Now, this one is a perfect square except for the fact that it's minus. We can't use the pattern if it's a minus 16. It has to be a plus 16 for us to use that pattern. So instead, I'm going to look for two numbers that multiply to get me negative 16 and add up to negative 6. So I'm thinking about negative 8 and positive 2. So x minus 8 and x plus 2. If I set that equal to 0, I see that x could be positive 8 or negative 2. There's my factored, and there's my zeros. So now I'm going to factor both of these and state the vertical and the horizontal asymptotes. So the horizontal asymptote I can do without even simplifying it. So we're going to go ahead and do that first. When I have the exponents that are the same, what's going to happen is I do the leading coefficient, which is 1 here, and the leading coefficient, which is 1 here, over top. So the horizontal asymptote for this one is going to be y equals 1 over 1 or 1. Now I actually do have to simplify it to get to the vertical asymptote. So to simplify it, what I should do is factor it. So I want two things that multiply to 21 and add up to 10. So I'm thinking x plus 7 and x plus 3. And now I need two things that when I'm multiplying, this is a perfect square trinomial. Multiplies to 9, adds to 6. That's x plus 3 times x plus 3. I like it when we get those patterns. I don't have to think too hard with that. So then when I simplify it, those cross out. So I'm left with x plus 7 over x plus 3. So I simplified. And then the vertical asymptote is found by identifying the 0 of the denominator, which is right there. So x equals negative 3. So there are my two asymptotes as well. And I'm going to do kind of the same thing over here. I'm going to write over here with the horizontal asymptote. The exponent here and here are matching, so I'm going to do the leading coefficient with this 3 over the leading coefficient, which is 1. So y equals 3 over 1, or just 3. Now I'm going to simplify. Now this, they all have a 3 in them, so I'm going to divide that out first. X squared minus 3x minus 10. So to get that factored, I'm thinking along the lines of negative 5 and positive 2, x minus 5 and x plus 2. Okay, and let's see. For the denominator, to get it factored, I need to multiply to 30 and add up to negative 11. I'm thinking about x minus 5 and x minus 6. So then when I simplify it, this factor goes away. I'm left with 3 times x plus 2 over x minus 6. And from the denominator of the simplified, I can get the vertical asymptote, and that is going to be x equals 6. All right. So in today's lesson, what we're going to be talking about is the multiplying and dividing of rational expressions. A lot of times we start with addition and subtraction and then work to multiplication or division. But actually, out of the two of them, multiplication and division is easier because multiplying and dividing fractions is easier than adding and subtracting fractions. Okay. Obviously, we don't have to worry about that piece. I didn't take that piece off. Don't worry about it, though. All right, so we're going to be taking these rational expressions that we've been simplifying and actually multiply them together and divide them. So here's our first one. It says perform the indicated operation, but you need to reduce first. It's just going to make your life easier if you take care of reducing things first. So the first thing I see is that I can reduce the 6 and the 9. They're both divisible by 3. So that can be 2x cubed over 3y to the 7th. And I can also reduce this 15 and this 12. They're also both divisible by 3. So that gives me y to the 5th, 5y to the 5th, and 4x. Now, when I multiply fractions, I multiply straight across the top and straight across the bottom. So that means we are multiplying 2x to the 3rd times 5y to the 5th, and we're multiplying 3y to the 7th times 4x. So I can actually simplify that now. 2 times 5 is my 10, and I have x cubed y to the 5th, and then in the bottom, 3 times 4 is 12, and I have x and y to the 7th. So the first thing I'm going to do when I get this answer, I got to go and simplify even more now, is I'm going to divide both of these by 2. So that's going to become a 5, and that's going to become a 6. The other thing I need to do is simplify the variables. So you can see I have 3 x's in the top and 1 in the bottom. So that just becomes 2 x's in the top. I reduce each one. And then here I have 7 y's in the bottom and 5 y's in the top. So it leaves me with 2 y's in the bottom. So really, multiplying rational expressions together is one additional step where we're actually just multiplying 2 things together in the top and 2 things together in the bottom. It's just a lot more to simplify when we get to that point. So we're going to practice a couple of these after we get done doing some division. Now, division is not hard. A lot of people think it's going to be like super, super, super hard, but it's really not. We've worked for a while on this, and every time we saw something like 1/2 divided by 3/4, we said, well, that's too hard for me to think about. And so we're just going to copy the first fraction, change it to multiplication, and reciprocate the second fraction. And we end up getting 4/6, and then we simplify it, which is 2/3. We're going to be doing that same exact process. The only difference is now we have variables mixed in. So the first thing I'm going to do is I'm going to get out of this division mode and put it into multiplication. And how I do that is I copy that first fraction. I change from division to multiplication. Because I did that, now I have to reciprocate this fraction. So it's 12y squared on the top and 3x on the bottom. So now I can multiply straight across. You can try and do some simplifying before you do that, but it's not going to hurt you if you wait. What do we get here? I believe we get 72 when we multiply 6 times 12. And we get x cubed y squared. And then we can multiply 4 times the 3 and get 12. And it's a single x and y to the 7th. So 12 goes into 72 6 times. So we just have a 6 on top. When I do that subtraction of the exponents, I'm going to get an x squared on top. And I'm going to do 7 and 2. So that's going to give me a y to the 5th on bottom. Okay. So let's see what we got. Let's try a multiplication problem. We'll try a division problem. Then I'll give you the extra time to work on it where I'm not going to talk all the way through the problem. All right, so basically what I want to do here is I want to multiply them together, but I'm really not going to multiply them together completely. Okay, I'm just going to combine them as a multiplication problem. I actually want to factor this thing first. So two things that multiply to -8 and add up to 2, thinking that's going to be x plus 4 and x minus 2. I'm going to put that 5 on there with it because I'm multiplying everything on top together. And then on bottom, I'm going to multiply the 15 by the x minus 2. And you can see how easy that becomes now that I put it in factored form in the top, because my x minus 2's can cancel. Also going to take a look at this 5 and the 15, because they're both divisible by 5. So that becomes a 1, and that becomes a 3. So it looks like my final result is x plus 4 over 3. And at any point in time, they could ask, what's the horizontal asymptote, what's the vertical asymptote, all of that stuff. Okay? But as long as we know how to put them together, we're in pretty good shape. So another multiplication. See if you can factor it first, and then see what cancels out. I'll put the solutions up. All right, here are our solutions. So this trinomial factored into 5m minus 8 and m minus 1. I just brought the 1 down. I really didn't even have to write that piece. Then I just brought the denominators together. And I noticed the 5m minus 8 canceled out. And so I wrote the simplified answer. Let's try another one. Okay. This time I'm going to have to factor all 4 trinomials. Okay. See what you can do with it. Pause it here. And then I'll put up the solutions. Okay, here's your solution. So this first trinomial went to x minus 12 and x minus 2. This one went to x minus 8 and x plus 4. The first denominator went to x minus 8 and x plus 1. The second denominator became x minus 12 and x plus 4. Then all of a sudden I got to start canceling some stuff out. I had matching x plus 4s, I had matching x minus 12s, and matching x minus 8s. So really, it all came down to x minus 2 over x plus 1. Okay, let's try again. Remember, this one has division. So the very first step you're going to do is recopy it with multiplication and then reciprocate the second. I'll show you this step, and then you should take some time to figure it out on your own. So I'm just recopying the first fraction. I'm changing from division to multiplication. Oops, almost did it wrong. Nope, I'm doing it fine. X squared. I'm going to take the denominator and put it as my numerator. And then take the top and put it as my bottom. Now I'll go about factoring and simplifying. Okay, 2x to the squared minus 4x. That had a common factor that came out. Adds to multiplies to negative 12, adds to negative 1, was negative 4 and 3. This was a perfect square trinomial. I could have written it as x plus 3 quantity squared. Sometimes it is actually easier to write out the two factors so that when you're canceling, you don't miss things. Okay? And then that was the difference of two squares. So we had minus 2 and then plus 2. So canceling can go like this. I have matching x plus 3s. I have matching x minus 2s, and I think that's all that matches. So the top becomes 2x times x minus 4, and the bottom becomes x plus 3 and x plus 2. Okay, let's give another one a shot. We've got 2 here. They're both multiplications. See what you can do with them. Put it on pause, and then I'll put the answer up. And there's your results for both of them. Okay, this one over here, everything in the denominator ended up canceling out. So it just got written like this. It wouldn't be necessarily wrong to write 4x plus 16, but it's not necessary unless that's the form, like a multiple choice answer or something like that, unless that's in that form. A lot of times, actually leaving it in factored form is beneficial because we might need to use that answer somewhere down the line in another part of the problem. So if it's already in factored form for us, it's more useful. Let's try some more. Work them out, and then I'll put up the results. Okay, here's your answers. You're simplified. So in this first one here, the 5's canceled out for me nicely. I got a little stumped when I got to this x squared plus 1 because for some reason my brain wanted to factor that, and you can't factor that. And then when I even wrote it down here, my brain wanted to say, oh, I can cancel some things out. They look just alike, but they don't actually, because this numerator is only to the first power and the denominator is to the second. So those are not the same thing, so be careful. And then when I came over here to the second one, I had that 5x squared listed first, so I went ahead and pulled the 10x cubed right over underneath of it because I knew they were going to kind of have to deal with each other there. And then this was the difference of two perfect squares, so it went x plus 2 and x minus 2. This was the perfect square trinomial. Remember last time I didn't write it as x plus 2 quantity squared. I wrote them separate, and I did the same thing here so I could see them canceling. Now when it came time to reduce the 5x squared over the 10x cubed, they were both divisible by 5, so I did that. And then when I looked at the exponents on the x's, I had one more in the denominator. So I ended up with 1x in the denominator. If it helps, go ahead and put parentheses around the top so you can tell that that wasn't part of these that got simplified. All right, let's try some more. We're still in multiplication. Just a lot of factoring and a lot of simplifying. Okay, see what you can do with it. And then I will put the solutions up. And here's your solutions. Everything in this one except for the 3 canceled out in the numerator. And we were left with this. You could have multiplied out that denominator, but I will tell you again, it is beneficial just to leave it in factored form. It helps out a lot more like that. And some people get confused with this and they think these x's can cancel, but that x is actually in a bracket with that plus 5, and this one is in the bracket with the minus 2. Sometimes we just don't write the brackets, but they're still there. Okay, so we have to be mindful of that. Let's try another one. And now we bring in the division. So remember with division, your first step is to rewrite the first fraction, change it to multiplication, and then flip the second fraction upside down. Give it a try, and I'll put the solutions up. Okay, so I copied the first fraction, I changed to multiplication, and I flipped the other one upside down. So then I was multiplying my 3 and my x squared minus 4. So 3 didn't factor any smaller. This was the difference of two perfect squares, so I had x minus 2 and x plus 2. And in the bottom, I actually brought the 6 over here, so it was lined up with the 3, knowing that they were going to have to deal with each other. And then the x minus 2. Those x minus 2's canceled out. And then the 3 over 6 reduced to 1 over 2. And again, some people get confused and think they can cancel these 2's out right here. But remember, just because they're not written doesn't mean those brackets aren't there. It can't be eliminated like that. Okay, and this one over here again, copied the first, changed it to multiplication, and flipped this thing upside down. So it was common factor in the first one. I'm left with x plus 3. This one was a perfect square trinomial, so I had x minus 5 and x minus 5. Then I just had the x minus 5 in the denominator. Then this one was the difference of two squares, so we have x plus 3 and x minus 3. So that's your result after you cancel out the things that matched. Let's try some more. Okay. Write it down. It's division, so remember to flip the second fraction. See what you can do. So hit pause now, and I'll put up the answers in a second. Okay, here's my solution. I did what I said. I copied, changed, flipped. In this one, there was a common factor of 3, so I got 3 and x plus 2. This one wasn't so easy. I had to do this one by grouping. I kind of did that in my head, but you guys could have shown it up to the side. But I ended up getting 2x plus 3 and x minus 5. This one in the bottom had a common factor of 2, which left me x minus 5. And then this one in the denominator, I also had to do by grouping. So I got 4x minus 1 and x plus 2. Okay. So it may take you a little longer to do these two because that leading coefficient's not 1, but eventually you'll get there. And then the x plus 2's cancel and the x minus 5 cancels. Okay, let's see what else we got. Okay, give this one a shot. A lot of common factors in this. And then I'll put up the solution. All right, here's my solution. I changed it from division to multiplication, so I flipped the second upside down. Common factor in 2x minus 26 was 2. The common factor in x squared plus 3x was x. The common factor in x squared minus 5x was x. And the common factor in 3x minus 39 was 3. Once I got done pulling out all those common factors, I had an x minus 13 that could cancel, and then the x could cancel. And then that's what we were left with. You don't have to put parentheses around the individual numbers in front. You can, doesn't hurt, but they're not necessary. Okay, let's try another one. This is division again. Okay, so see what you can do, and then I'll put up the solution. All right, so again, I took the division and multiplication, and I flipped this fraction. Adds to 9, multiplies to 18 was 6 and 3. This one had a common factor of 3. This one multiplies to negative 15, adds to 2. That was positive 5 and negative 3. And the last piece had a common factor of 2. You can see my x plus 6 is canceled, and so did my x plus 5s. And there's my result. All right, last problem. Give it a shot, and then I'll put up the solution. Wow, this was a tough one. I couldn't do a lot of this one in my head, that's for sure. So you can see over here in the pinks, I was actually doing factoring by grouping. I actually showed my work right here on the screen for you. The first thing I did was change it to multiplication and flip the second fraction. So when it came to the 2x squared minus 5x minus 12, I came over here and did factoring by grouping and said that what multiplied to negative 24 and added to negative 5 was negative 8 and 3. And then that's how I came up with my two factors there. And with this one, what multiplied to 6x, or 6, and added to 7 was 6x and 1x. So that's how I got my x plus 3 and the 2x plus 1. And then I moved to the bottom, and this was ugly too, so it was what multiplied to 12 and added to 8. And what I got was 6x and 2x. So I did my factoring by grouping to get the 2x plus 3 and the 2x plus 1. This last one was the easiest part. It was the difference of two perfect squares, so it gave me x plus 4 and x minus 4. And then it became kind of pretty because my x minus 4 is canceled, my 2x plus 3 is canceled, and my 2x plus 1 is canceled. I was only left with one factor in the numerator and one factor in the denominator. So it was a little bit more difficult to get the factors, but you can see it ended up pretty nice in the end. All right, so what you're going to do now is you're going to go do the closure. You have one multiplication problem and one division problem on the closure. So make sure you get that done and you get that submitted so you can get a grade for today's class. Next class, we're going into addition and subtraction.